This is the screencast for section 4.3, example 4. Here's what you've been waiting for. What is a reference triangle? I know I've had you on the edge of your seats. All right, well, a reference triangle is this triangle formed by connecting the terminal ray and the x-axis with the segment that is perpendicular to the x-axis. X-axis, x-axis, x-axis. It's very hard to say fast 3 times. Try it. See, told you, you messed up. All right, so example 4. Evaluating the trig functions of 315 degrees. So we're going to go back to degree mode for a little bit to kind of give you an idea, a little bit clearer picture of why this reference triangle thing works. So I'm going to put a 315 degree angle on the coordinate plane in standard position. So my initial ray is of course going to go along the positive x-axis, and then my terminal ray, let's see, 315 degrees. Well, 360 degrees is a full circle around, so that's not a full circle yet, but it's 45 degrees short. So it's going to go halfway through quadrant 4. So I'm really trying to find the trig functions for that angle, theta, the counterclockwise angle from the positive x-axis all the way around through 3.5 quadrants. So that's 315 degrees. Ooh, which I'm not going to call that theta, I'm just going to call that 315 degrees. Because remember, theta is always radians. What's genius about reference triangles is the fact that I can use this tiny little triangle in here to find all the trig functions of 315 degrees. Now remember, when we were figuring out where to put our terminal ray for 315 degrees, we discovered that this inside angle, there were 45 degrees left over. So this is 45 degrees. I can use the sine, cosine, tangent, secant, cosecant, and cotangent of 45 degrees to help me find 315 degrees. Specifically, I'm going to look at drawing a reference triangle, and since you know that this is going to be a 45, 45, 90, we can pick that the hypotenuse is square root 2, the x-coordinate here is going to be 1, the y-coordinate is going to be -1, so this point located on my terminal ray, just for frame of reference to the other problems, is 1, -1. So now essentially I'm using this little 45 degree angle to help me with my 45, 45, 90 to be able to come up with all of my my trig functions, my 6 trig functions of 315 degrees. The only difference between the 6 trig functions of 45 degrees and the 6 trig functions of 315 degrees is that anything involving the opposite side is going to be negative. So that means, let's see, sine would be negative. Anything opposite? No, not cosine. Tangent will be negative. Cosecant, yep. And cotangent. Those are all going to be negatives because the opposite side, unlike 45 degrees, which would be in quadrant 1, the terminal ray is in quadrant 4, so the y-coordinate is negative. The opposite side is negative. So here are your 6 trig functions of 315 degrees. Again, I found them by using a reference triangle. I let the angular distance between the terminal ray and the initial ray create the ratios of my triangles. And trig functions are ratios. Trig functions are talking about the ratio of the opposite side to the hypotenuse, the adjacent side to the hypotenuse, etc. And this reference triangle thing will work for all degrees and all radians, no matter what you use, as long as you draw a perpendicular from the terminal ray to the x-axis. So let's look at the now try problem number 25. I'm going to draw a 120 degree angle in standard position. Let's see, 120 degrees is not quite 180. As a matter of fact, it is 60 short of 180. So here's 120 degrees. So I'm really looking for the trig functions of 120 degrees, but instead I'm going to use the reference triangle of 60 and then use the reference angle of 60 degrees. So now, since I dropped a perpendicular down to the x-axis, you have a 30, 60, 90. So the only difference between the 6 trig functions of 120 degrees and the 6 trig functions of 60 degrees is that anything that has the adjacent side used in it, any trig function that has the adjacent side is now going to be negative because the terminal ray of 120 degrees is to the left of the y-axis, so the x-coordinate getting up to this point would be negative. Matter of fact, this point would be, let's see, negative 1 square root 3. Now number 25 is specifically asking for the cosine of 120 degrees. So the cosine of 120 degrees, well, that does use the adjacent side that's adjacent over hypotenuse, so that's going to be negative 1/2. The cosine of 60 is positive 1/2 because 60 is over in the first quadrant. So since we moved over in quadrant 2, the x-coordinate is negative. The adjacent side is negative.